Good morning, Europe, and good afternoon to those in Southeast Asia. I'm excited to welcome you to today's webinar, where we will be discussing about trends and pitfalls in the IoT sector in Southeast Asia. This webinar is co-organized by the Southeast Asia IPR SME Helpdesk project and UnaBiz. I will be today's webinar moderator, and joining me shortly will be two outstanding speakers, Jonathan Tan, Managing Director of UnaBiz, and Jonas, Lindsay, external experts of the Southeast Asia IPR SME Helpdesk and Senior Associate at Marks & Clerk. But before we dive straight into that, let's have a quick overview on the webinar platform to make sure that you all familiar with it. So how this webinar platform works, we will be recording today's presentation, and you will receive it through a follow-up email after the session, and we will also upload it to our website if you'd like to access to it again. If you have any questions during the webinar, please type in through the question box, and we will discuss it in live through the Q&A session. And we will also launch some poll questions, so please intervene during those poll questions so we can hear your thoughts and discuss it later. And let's have a quick look at today's agenda. So I will give you a quick overview to the Southeast Asia IPR SME Helpdesk project. After, John will update you on what to know about IoT trends in Southeast Asia, especially focusing on Singapore. And after, Jonas will highlight some challenges where you should watch out for to make sure you do business in a safe way. And we will wrap up with an interactive Q&A session. But before we get started, just a quick update on what the Southeast Asia IPR SME Helpdesk is doing. We are a project funded by the European Commission to support small and medium-sized enterprises from the European Union to protect their intellectual property rights when they do business in Southeast Asia. All services offered by the project are free of charge, so it's a great support for startups and SMEs who would like to take timely action before entering the Southeast Asian region. So on this slide, you can see the services that we offer. So for example, we have a helpline throughout which you can get in touch with us and ask any IP questions you may have. It can be via email or an online call or a telephone call. We also have a wide range of publications available on the website on various IP topics, sector-specific topics, or also country fact sheets focusing on the 10 ASEAN countries. We offer training opportunities across Southeast Asia and also in Europe, especially online these days. And we have some interactive learning tools, for example, e-learning modules to learn about IP in a funnier way. So without any further ado, I would like to pass the floor now to Jonathan. So Jonathan, you will be able to share your screen and show the webcam. Yes. Hi, Jonathan. I can see you. I confirm.
All right. Hello. Hi, I'm Jonathan. I'm the Managing Director, UnaBiz Singapore, and I will share with you very briefly about IoT. All right. Can we share the screen? Thank you so much.
Yes, you should be able to share your screen. So if I think you should open the PPT.
Okay, I'll do that.
I think it's easier if you control your slides.
Okay, I'll do that. Give me a while because the computer is a bit slow.
So just if you can put it on full slides, full screen.
Okay.
Is it possible to put on full screen?
Yes, hold on. I already did it. Do you have full screen now?
Yeah, perfect. Thank you. Great.
Okay, good. All right. Okay. I'll just do a quick introduction of ourselves. What do we do? Okay, we are a IoT company, and in the last 4 years, we've been doing IoT stuff. All right. So so far we have revenue about $15 million, and we are profitable. And also we have annual growth of 240% every year. right? And we are also 9,000. We have deployed lots of projects. And we have also just some of our customers. We have Nichi Gas from Japan, Singapore Airline, in Taipei Waters, Airbus, Sorocom, and a few others like KT Hospital and so forth. And our product has been sold over 70 different, 30 over countries, right? So let me just run through a little bit of IoT. I'll just do a quick introduction. All right, you see a little car at the side there at the left, and all right, we have a car that's normal. So you may put some dashboard to it, so you have a car that's actually have some intelligence. And then in this intelligence, you can also be connected to the internet. And then with this car is connected, you can then have some information like GPS, radios, data, and so forth. And what if, let's say, there are also other systems in the country, like maybe there are some street lamp projects doing some surveillance, there are some parking apps, there are maybe some hospital staff that you want to monitor. So there are different city infrastructure of smart system. And the thing is, a real IoT system that is also not just connected system, but it's also systems of system, whereby all the different systems can be connected to each other, and the car can then communicate, so that when it's not just driving, but you also can see information like perhaps the infrastructure, like is there any traffic jams, is there something with the public security that connected to the car, or if let's say you go to the meeting and so forth. So these are all internet connection, internet connectivity in here. And if you look at it, the other way is seeing it is that if you look at a vertical plane, this is the reach of the system. From an IoT has evolved. It used to be called end-to-end machine learning, machine to machine. Then it became IoT, and Cisco even call it the IoE, Internet of Everything. So your machine connecting the objects to people and to the world. And on the horizontal plane, you see it's from the virtual world to the physical world. So an example of it is perhaps maybe just a simple app on your phone. It is all in the virtual world. But then when you move more and more into the physical world, right, that is where IoT starts. And you move from machine to objects, people, and so forth. And eventually everything can be connected in Internet of Everything. Right? So if you ask again, what is that? How is the architecture typically like? So it is usually, if you break down IoT, it's just this very small, very simple stuff. All right. It is on the left here. It starts with the IoT devices, the sensors. The sensor that's up there. So the sensor could be collecting a machine, reading from machines, or it could be temperature sensors, or it could be a tracker that's out there. So it is a little sensors that collecting physical data and putting it onto IT. Then you will then be sent over a network. All right, a network could be cellular, could be and it could be LPWAN and so forth. And then the network will then go to a platform, and the platform will then ingest the data, put it nicely into the right readable format, and then you will then go into the software. And then into the software, that is where the data can be ingested, and the business value can be harnessed. So that is where all the big data, the analytics, machine learning comes in, and the human can then see and act upon it. So typically there are these 4 areas that comes together to form an IoT architecture. All right. So IoT is not just a one simple stuff, but it cut across various different kind of technology, which sometimes means it can be a bit complicated. All right. So, and on the network side, we also like to share with you maybe a trend. All right. If you look at it, since the 1980s, we all have handphone, right? And we're familiar with the 1G network. Then moved to the 2G, then the 3G some years back, and 2-3 years back, everybody got excited with 4G, but now everybody's talking about 5G. And you can see that as the G get higher and higher, that generation, the network get more and more complex, and the data get higher, better. The bandwidth is higher, and then the latency is actually narrower. So it actually allows us to do bigger and bigger and faster and more kind of heavy applications as we move from 1G to 5G. But sometimes in the IoT world, it's not necessary that you want to have such powerful network to run your stuff, all right? Because many times in IoT, you want breadth rather than depth, all right? For example, the iPhone here, it is depth, all right? The bigger, the better, all right? The more powerful, the better. But on the IoT, perhaps you're looking at a temperature sensors, or perhaps you're looking at a meter reader to be able to pick up a data from a machinery to tell you, is it on, is it off, or what is the sensors reading, and so forth. So you do not need very heavyweight kind of network. A very simple, very lightweight network will be good enough, and so that you can actually, it is cheaper, consume less battery, consume less cost, and you can then deploy it in a much wider field, right? So that's why in recent times, people are beginning also to not just about 5G, but also to talk about 0G, going back to the opposite, whereby the radio frequency, using simple radio frequency, very lightweight devices, something like your car key, tick, tick, like that, and you're using very simple stuff to collect data. And this with low power, low cost, ultra long range, and global. So there are different kinds. So I just, in short, I have done with you a very simple outline of IoT systems. All right. So along the way, if any question, feel free later to mark it down, and I can answer later in the Q&A session. And now I'm going to share with you, all right, some of the use cases that we see here in Asia, particularly in Southeast Asia and Singapore. All right. All right, so one of the areas that IoT has been gaining a lot of traction recently is in the smart facility area within the building. All right, I think maybe because in Singapore everybody sits inside the air-conditioned room, and we want to be able to optimize the functionality of the building to be able to deliver more with less people. So in the last few years, we can see a lot of our opportunity within the smart building area. And I'm going to share with you one of the very early projects that we did maybe about 2 years back, all right, beginning IoT, is when we deployed lots of temperature sensors in this nice building called the KK Hospital in Singapore. What the hospital at one time is that because they have temperature, they have lots of different critical medicines, all right, kept in their hospitals, and they need to keep them in an optimum temperature, all right, and this need to be monitored, and this need and regulated. And so what we did for them is that we put temperature sensors in the building itself, and so that we can monitor them, we can see any trends, and we can also highlight to the facility managers if there's any kind of abnormalities. And the thing is, the temperature sensor that we put in here are IoT systems, whereby it's very simple to deploy, all tiny little wireless, and it can be then plugged in and play in all the various buildings. And if the thing is, if they want to do the traditional system on wire, it will take them lots of the cost of cabling, disruption to the hospital is going to be a lot more. But if you can do all using wireless, low cost, long battery life, 0G network sensors like Sigfox, all right, you can actually deploy it very quickly at very low cost with minimum disruption of installation. So that was actually one of the first projects we did in the very early days. And since then, you moved to so many other things within the hospital, all right? So they also now use it also to monitor also human counter, the flow of people, how many people are moving in and out of the buildings. And they're also looking at using it to monitor also tracking of devices and tracking of assets moving within the hospital as well. All right, so this is one of the stuff we do. So the other thing is also in managing the building is to look at also within any anomaly, anything that's out of the norms. All right, so recently we deploy leak detection sensors, water leakage sensor within the buildings. And this is a very famous airport, which is a jewel that we installed in Changi Airport, Singapore Changi Airport jewel. So we put sensors in the building itself because there's so many greeneries in there. All right. So, and the sensor will then detect not only human flow, but also the performance of the buildings and any leakages of in the building. So sensors are then put all around, and if they don't do that, all right, if there's any leakages, it happens, all right, and the cost of managing and repairing is a lot worse, all right. So this has been deployed. So it actually helps the customer then to see, and they can all be able to then get any notification if there's any anomalies. All right. So besides this, there's also sensors like rodent sensors that we have deployed Just imagine, all right, every single building that we actually know about where there are food, we didn't realize that there's actually rodents in there. It's just whether you see or you do not see them. So what we did is that we actually put rodent sensors in the rooftops of the building, and thereafter it is so that we're able to trace where are the movements of the rodents, and with that we are able to tell the facility guys and the pest control guys where to target them, right? So there was an example whereby we actually told a customer, hey, let's do this about this system. And the customer said, no. Our building is AAA, all right, class A. There's actually no pests in the building. But but nevertheless, they did a trial. They installed these rodent sensors. And imagine in this particular building, which is very famous, within 2 weeks, they actually monitor and track out 11 rodents in the building. So they was very surprised, and they actually asked to install IoT sensors in there. And IoT, so that is actually, and because the thing is, all these sensors are able to put in and detect data where in areas that human doesn't like to go in and unable to go. And it's going to operate 24/7, and sensors all work autonomously. And the other thing I will also share with you, besides buildings, is actually the one of the things that actually one of the greatest structure for us is, and we are all very excited about, is metering. All right, this is a project that we did in Japan. All right, and for Nichi Gas. Nichi Gas is the largest gas operator in Japan, and these guys, they are looking at how they are able to collect data from all their gas meters. All right, so currently how the people do it is obviously getting guys to go down on the streets, collect data and so forth. All right, and that can only be done once a month and require intensive and huge amount of people and human resource to do that. And in these days of COVID, in these days of where we want safety and social distancing, we want to be able to reduce the human out there, right? We want to minimize. If a machine can do it, to collect data, it is actually a lot more cost effective. And also, it doesn't depend on managing huge number of people to go down. And we can also collect data continuously every day instead of once a month. And with that, a lot of data can be collected, and you can see the trend, and you can actually have the analytics to be able to manage the services a lot better than just merely once a day, just ordinary building, right? So the Japanese guys approach us for a solution, and we are able to deliver for them a solution that costs 4 times less than the competitors, because we are able to help them design a system cost effectively. And so this is an example of the sensors in there. All right, it's nice, it's very beautiful. It's not just all boring, bulking stuff, but we also design the aesthetic of it, because they see that all these sensors, it's out there in the field where the customer are. So you need to be able to market your product as well. All right, that's why we design it nicely. And for this, we actually deployed about 850,000 of this meter, of which currently about 450 has been deployed. So I must say that this is actually an amazing project, because the Japanese guys is well known. All right, they are not slipshod. They are very careful. They are very diligent. They are very precise, and they have made their studies, and they believe that this is the best way to move forward. And after we have deployed this, they actually contacted us to deploy a lot more sensors, because they do see that the trend is moving forward in this. All right. So in the same way, we do see that gas meters there's also huge interest in Indonesia, and of which we are, and also in Thailand. And right now we are also speaking to the people out there. The next thing I also share with you is, besides gas meter, is also water meter. Water meter is also very big projects. We recently got a project in Taiwan, and Taipei is actually looking at it actively. All right, and they're putting meters. So these are the meters that you can see out there deployed. And right now it's still in the early trial stage, and the customer is still saying which is the most optimal way of doing it. But eventually the plan is to actually digitalize the entire metering process using automatic meter reading. Singapore as well is also doing this. Currently there is a tender going on for about 300,000 gas meters in Singapore. All right, and currently about 7 bidders bidding for these things, and all the world best companies bidding for this right now. We are also part of these things. All right, and eventually Singapore plan is also to automate and all of this water and gas metering. Okay, I move a little bit, change the tone a little bit into something else, different kind of IoT application. This one is for the smart asset tracking. All right, I believe okay, now it's still a bit early. I believe all of us drink beer, right? This out there you see are not not boring cans, but these are beer cans containing our beer. So we are doing a project in Australia, whereby this customer have hundreds of thousands of beer cans moving around Australia. Right, so the factory, they produce a beer, fill it up, send it to the bar, and collect it back. So in the old days, all this will be done. The tracking will be done manually, and many times some of the bars they forget to replenish on time, and their turnaround cycle is slower, or sometimes the beer can get lost, disappear, and so forth. So what we did is that we have them design a simple tracker that can put onto the beer cans, and as you move around within the supply chain or within the factories and the bars and the warehouse, it is able to then track precisely where is the location of this. And why do they want to do that? So by doing that, they are able then to reduce the number of the supply chain cycle, and they are then able also to know where are they, and they will cut on loss, and they are able also to make sure that the replenishment of beers and moving around is optimized, and there's no empty one lying around. And it's only not just managing of the location, but we are able then to also monitor the quality of the beers by looking at the temperature to make sure that it's in the right storage and kept in the most optimum temperature to keep our beer fresh, and as well as able to track the process. All right, we put sensors in there so that as the beer get mounted onto the beer can get mounted onto the bars, we know that it's on, and when you take out, we know that it's off, because by just tracking the movement of the beer cans itself. So with that, we are able then to see and also pick up marketing information, how far it can move, who is moving how much, and so forth. All right. So actually, if I may share, also a very similar experience. Right now, we are also working with another company, still in the early stage of monitoring the ice cream boxes. All right. So these ice cream boxes, you see the one that is the refrigerator that moves around. The customer actually first engage us to monitor where are the location of all these ice cream boxes as they move, because some of them they get lost, right? But along the way, they realize, hey, what if they put in sensors to detect also the temperature, so that they know that the ice cream is kept in optimum temperature? What if, because if not, what if along the way there's a power blackout and all the ice cream melt and then it got frozen again, and means it's unusable. But if you have and nobody know. But if you have a temperature sensors in there, this thing can be alerted so that somebody can make sure that it's rectified. And then we look at, what if we put in additional sensors about the opening and closing of the ice cream box? All right. And also, what if we put additional sensor on the box itself, so that we know how many people walk past the ice cream box? And we are then able to track the utilization. How many people walk past? So is this a good location? And how many people actually open it? All right, so that they see if there's any interest. And we actually finally put a weight sensor on the ice cream box, so that they know whether anybody take out ice cream, right? So that they know that people moving, people opening, and people taking, and they can then see the consumer behavior, right? And that will actually be extremely valuable as they move forward, right? To be able to plan how to deploy out the ice creams, right? And market it, and which are the brands that sell, which are the brands don't sell. And finally, the weight of the ice cream box also help the customer then to see, they help the supplier then to see when to replenish, because oftentimes many of these retailers, they forget to replenish the ice cream when it's time to. So the stocks go very low, and it's low means customer will not buy so much. Then of course it means loss of revenue. So if they're able to monitor and keep the supply at the optimum level. So all these are possible, all right, and with very little effort if we put in IoT system, so that you don't need humans, but data can be collected automatically, and analytics and customized result can then be done. Yep. All right, I move on. Also, the other thing is, this is a project right now. We are working with the Singapore Airline together with Singapore government IMDA, whereby we help them to track the ULDs, the unit load device. Can you see the little box that's out there, the big box down there that contain all your luggages. All right, so SIA have about 19,000 of these boxes moving around the world, all right, at the ship. So currently, the monitoring of where it is and so forth are all done manually. So, and many times the supply and the demand cannot be managed properly, because sometimes when things changes, they can do, and you get all on the hand, it got mixed up with other airlines and so forth. So what we did for them is that we put in a sensors that is able to follow the airlines globally as they go around the countries, and it's able then to track the location of these boxes through GPS, through Wi-Fi geolocation, and then to Bluetooth, all right, sensors, so that we know that whether it's in the airport, is it in each country, or is it in a warehouse of a partners. And all this data is collected and sent via the 0G Sigfox network, because it's a global network and can last a long time. And this sensor can last about 3 years of autonomy. All right. So it is a project that has been successful. And SIA is now, so far they deployed in a small area. They are now looking at how to be able to deploy it on a mass scale. All right. Because these are sensors that can last 3 years, and they can both track indoors and outdoors. All right, lastly, I also want to share about things like smart parking. This is a project we did in Taipei as well. All right, so parking is definitely an area that every city will have. So we put sensors on the floor. All right, so then the sensor on the floor is then able to track the utilization of the parking lots, and then thereafter help the municipal department to be able to plan out the utilization, where the free lots, how can they do billings, and how can they help customers to be able to reach out to the empty lots. And so these are our little sensors on the floor, right? So you see that in general, all of these things are very simple, tiny little projects whereby we deploy. And if you ask me, IoT, when we started out 4 years ago, everybody is talking about, oh, what's next, what's the use case, and so forth. But today, we are beginning to see more and more sensors being deployed, and the project getting larger and larger. And today, the number of sensors that we have deployed and that we are in the midst of deploying is about 1 million plus sensors. It's just for our company alone. All right, all running mainly on the Sigfox 0G network. All right, so it is ranging from metering, ranging from asset management, ranging from also smart facilities and so forth. So there are many possibilities. All right, so I'm going to pass this time now to Jonas, all right, who will talk to you more specifically on intellectual property. And thereafter, if you have any question, feel free to ask you at the Q&A session. All right, thank you.
Thank you, Jonathan, for this very smooth presentation with great cases. I think that was a good idea to share some ongoing projects and practical examples with the companies. So now I would like to hand over it to Jonas. So you can now share your screen, Jonas. We can also see you, great. Yeah, great, I see your presentation full screen. Thank you, so the floor is yours.
Okay, so thank you very much. So my name's Jonas Lindsay, and I'm a patent attorney working here in Singapore. I initially started working in London, but I've now been in Singapore for about 5 years, and I advise clients on various IP law matters, but particularly patents, and particularly patents relating to computer software and electronics, and of course IoT is kind of a very relevant part of electronics developments in computer software and electronics. Excuse me. So today I'm going to briefly kind of introduce IP and talk about the types of IP that exist, and then go over the economic value of IP, and I'll specifically mention various types of IP and issues in IoT, and then I'll specifically concentrate a bit on patents and some specific issues relating to patents for IoT. And then finally, I'll make some conclusions at the end. So first of all, what is intellectual property? So IP gives the owner a limited monopoly. So for example, a patent protects an invention and gives the owner of the patent the right to stop other people from using that invention. It's one important thing to bear in mind about IP is generally it's a negative right. So it gives you the right to stop other people from doing something, but it doesn't, apart from that, it doesn't necessarily give you the right to do something. So having a patent doesn't necessarily mean no one else has a patent on a similar product that could stop you using an invention. It just means you could stop other people from using an invention. The main types of IP are patents, confidential information, trademarks, copyright, and registered design. IP rights are generally territorial and limited in duration. That means, taking patents again as an example, that if you want to protect an invention in Singapore, you need a patent in Singapore. But that won't protect you from, that won't allow you to stop other people from using your invention in, say, Malaysia, for example. You would also need a patent in Malaysia to stop people from using your invention. And IP rights generally are limited in duration, and trademarks potentially last forever if you carry on renewing them, but most other IP rights have a finite lifetime. So now I will ask the first of the poll questions, and this is, have you ever applied to register any of the following IP rights? Patents, trademarks, other, or have not applied to register any IP rights?
Okay, so we will keep the question for a few seconds, and then we will share the result and you can comment on it, Jonas. Okay, I think we can share the result now. So it seems that our participants have done already part of their homework. 60% registered a trademark and 20% patent and 20% other IP type. And no one said they have not yet registered an IP. So let's see what you think, Jonas.
Okay, well, that's quite interesting. So actually all of you have registered some kind of IP rights. I often find that the first type of IP that people come across is a trademark, because trademarks kind of apply to the broadest range of businesses. So for example, if you're a dealer of articles, if you own a shop or something, you may register the trade name of the shop as a trademark, but you may not be kind of developing original products yourself, so you may not be able to register a patent. And another thing to say is that patents are very expensive to register, and often trademarks are sort of relatively less costly to register. So often they're the first type of IP that people consider. So it's good to see that lots of you are familiar with IP, and as I was saying, it's often it's trademarks that people are registering first. So that's not a great surprise. Okay, so now I'll move on with the rest of the presentation. So now I'll briefly talk a bit about the economic value of IP. As I mentioned or alluded to earlier on, there's a cost to registering IP rights. So if you have a business and you're going to incur a cost, you want to get something back from that, some economic value.
Sorry, Jonas, I don't see your screen. If you can put it again. Yes, perfect. Thank you.
Okay. So yes, so the so IP provides a limited monopoly, and the owner of that monopoly can profit from the monopoly. So the simplest way to use IP is if you have a right, you can stop other people from using, that's, for example, the invention that's covered by your patent. So you can profit from selling those products that no one else can make and sell in that country. So you can charge a premium and you have a limited monopoly on those products. So that's kind of the simplest way to gain return on IP investment. Another possibility is to license your IP. And that is if you're not using it yourself, or if you're using it and someone else is using it, but they pay a royalty to you for allowing them to use your IP. And there are many different ways of licensing products in terms of the type of license you have, the way royalties are charged. So you could charge someone a flat fee, and then they could sort of use the IP as much as they want, so sell as many products as they want, or you could charge a royalty per product sold, or a percentage of the revenue earned from selling a product. Another possibility is you can have a cross license. So if you have a patent that covers an invention that someone else wants to use, and they have a patent that you want to use, you could agree to cross license. A third important thing about IP is it attracts investors. It's one of the sort of key things that investors in particularly startup companies look for, is they look for sort of what is the value of a startup company. And often the two main things that a startup has is the people and the knowledge, the IP. So a key factor that investors look for is having some registered IP in the company. So that can make a startup company much more attractive to investors if they have some, if the company has ownership of some IP. So now I'll briefly talk about the different IP types. So first of all, patents. Patents protect inventions, and they can be defined either as a product or as a process, or as both. And to be patentable, an invention must be new and inventive and include patentable subject matter. So something being new in patent terms means it must have not been disclosed to the public before patent application was filed. And that covers the whole world. So if something's published in, say, the US, that potentially prevents it from being patented in anywhere in the world, including Singapore. And another important aspect of that is that a disclosure by the applicant themselves can invalidate a patent application. So if you have an idea and you disclose it by selling products, or by publishing it in a scientific paper, or by writing about it on a blog on the internet, that can potentially count against your patent application if you publish it before you file the patent application. Some countries have grace periods. So Singapore, for example, has a grace period. The US has a grace period, but not all countries do have grace periods like that. So the UK and European countries don't have such grace periods. So any disclosure, including by the applicant themselves, is potentially fatal to a patent application. So it's very important, if you have an idea that you're thinking about patenting, to make sure you get an application on file before you disclose your idea, because otherwise you may be limited in where you can protect that idea with a patent. The next criteria is that the invention has to be inventive, and that means the subject matter must not be obvious. And there's different countries have slightly different tests for this, but basically it means there has to be some kind of advantage to the invention that wouldn't be very easily derivable beforehand. So it's not just a sort of workshop improvement that you've actually come up with some valuable idea, but it doesn't have to be a sort of a huge inventive step or a huge advantage. There just needs to be some technical advantage to the invention to make it inventive. And the final criteria is that the subject matter must be patentable. And often IoT inventions will be software-based. And whether or not computer software is patentable is very complex, and it varies between different countries. And generally, Southeast Asian countries follow a similar approach to the European Patent Office. And that means thinking whether the problem solved by the invention is a technical problem. And if there is a technical problem or a technical effect to the new parts of the idea, then it generally will be patentable. And often, it's often the case that sort of IoT-related inventions will satisfy this, particularly if they involve sort of data being transferred faster, or data being transferred more securely, or increasing accuracy of sensors and reducing processor load. Those kind of things are regarded as technical. So generally, particularly where you have either sensing or transfer of data between different parts of a network, that sort of subject matter generally will be patentable. Sometimes there can be issues where it's more kind of business processing. So if it was to do with, say, billing for gas meters, as Jonathan talked about earlier on, if it's purely related to billing and calculating billing amounts, aspects like that may not be patentable, but certainly aspects to do with kind of determining how much, measuring, gas usage and transferring data around about the measured gas usage, things like that generally will be patentable. The next type of intellectual property that I'll talk about is confidential information. This is slightly different from the other types of IP, because this isn't a registered type of IP. This is more just an action that you can take, and it's relatively simple. It's you protect an idea by keeping it secret, and because you keep it secret, no one else knows sort of how to use a method, for example, and then you can possibly process data more efficiently, and other people can't use that processing. So, for example, if there's a process that's implemented on a server that other people can't see, then you can protect that by keeping it confidential, but without, for example, filing a patent application. This only really works if the idea cannot be reverse engineered. So if it's part of a product that's given to customers and that your competitors can take away and revert and look at how it works and reverse engineer it, then it won't work. It can also apply to non-patented ideas. So if you have some processing going on a server that is not really patentable, so it's more to do with business processes, one option is to keep that processing secret and then protect it using confidential information. An important thing to bear in mind is that patent applications are published after 18 months. So you can't protect an idea for a long time with a patent and by keeping it confidential. You need to make a decision on whether you want to keep it secret and then not file a patent application, because part of the application process is this publication, or whether you want to file a patent application and acknowledge that that would mean the idea will be released to the public and you'll use the patent to protect your idea. The next type of intellectual property I'll talk about is trademarks, and trademarks protect brand names, slogans, and logos generally. It's also possible to protect sort of so-called non-traditional marks like shapes, colors, and even smells in some countries. Trademarks are registered for specific classifications of goods and services. So if you want to register a trademark, in your trademark application, you include your mark. So that may be, for example, a word mark, a slogan or a logo, but also you include which classifications of goods, services you're going to use it with. In some applications, you may be able to protect various different parts of of your sort of that you use in your business as a trademark. For example, if you have an app or a computer program, you may be able to protect the name as a word mark, but also the icon as a logo as well, and that way kind of build up a broader protection of different parts of your trademark. One important thing to say is it's important to check the availability of your mark before you launch and enter new markets. And one thing that does occur in Southeast Asia sometimes is sort of trademark spotting, where someone will see a trademark being used, say in the US or Europe, that isn't registered in Southeast Asian countries, and will try and register that in Southeast Asia, possibly without the sort of the original company knowing about it. So even if you have a trademark registered in some countries and you're moving into new markets, it's important to check the availability before launching and moving into those new markets. The next type of IP right is copyright. And copyright gives the owner the right to prevent other people from copying a work. Copyright is slightly different to trademarks and patents in that it doesn't always need registration. Copyright exists once a work's been recorded. So if you take a photograph, or if you write a book or a novel, or if you write a computer program, as soon as that is recorded, as soon as an original work is recorded, you have copyright in that. For IoT type applications, often software and computer program code will be protected by copyright. An important thing to bear in mind is a limitation of copyright. Copyright protects the implementation of an idea, not the idea itself. So if you come up with a new data transfer protocol for transferring data between IoT sensors and a central server, and you write a computer program that implements that data transfer protocol, your copyright will protect the program that you've written that uses that protocol, but it won't necessarily stop someone else from writing their own computer program that implements the same protocol or a similar protocol. You would need a patent to protect the underlying idea. And finally, the final type of IP I'll talk about is registered designs. Registered designs generally protect physical products, so they protect the appearance of the product, but not how it works. So that's often like the shape of a product. So often you see things like mobile telephones, the companies will register the shape of the handset as a registered design, but they may also have patents for the internal workings of how the mobile telephone works. Some Southeast Asian countries, Singapore, Thailand, the Philippines, and Malaysia, also allow registered design protection for graphical user interfaces, and that can provide a relatively low cost way of protecting some aspects. So if you had, for example, some kind of dashboard that showed various sensor information to a controller or to a user, that dashboard might be registerable as a registered design, and that the cost of registering designs is generally low compared to patents. But they only protect the appearance and not the functionality. So going back to the dashboard example, someone else could potentially make a similar dashboard that had a very different appearance, and in that way avoid infringing a registered design, but they might implement the same kind of underlying functionality. So now I'll talk in a bit more detail about patents, because there are some sort of more relevant and detailed issues that are specific to patents in IoT devices. The most important part of a patent is the claims, and these are sort of small sentences or paragraphs at the end of a patent, and they define the protection that the patent gives. And the claims can define a device, a system, a method, computer readable medium. But when we're framing those claims, it's very important to consider how the invention will be used and will be solved. So for example, a digital distributed system where you have a server and multiple devices in communication with the server, it's important to think about where the invention takes place, and how best to define it in the claims. Because if the invention just takes place in the server, then it's important to have a claim to just the server itself, because otherwise if there was just a claim to the overall system, just a server or just a device might not infringe that claim. So the best way to get the sort of strongest coverage and protection is to have claims that cover each individual part, and particularly if those parts are going to be sold separately, protection for the parts that as granular as the sales will take place. Some countries have provisions for what's known as contributory infringement, and this is effectively means that if you sell part of a system that you know is going to be used in a larger system, and there's a patent for that larger system, and the only way that component could be used is in that larger system, then that may infringe the patent under contributory infringement. So in the Philippines, there are provisions for that, but most other Southeast Asian countries don't have such provisions. So Singapore, Vietnam, Thailand, and Indonesia don't have such provisions. So in those countries particularly, it's important to have claims for the individual components of a system, but those individual components have to be novel and inventive in themselves. Another important issue relating to patents is standards. So many IoT developments are related to interoperability, like data transfer between different parts of an IoT system. And these may be relevant to future standards. So standards are often apply where there's interoperability between components of parts of the system and where there's multiple providers. So for example, there are DVD standards and there are sort of MPEG standards underlying that. There are also lots of wireless data transfer standards such as Bluetooth and 5G, and lots of companies have lots of patents relating to all those standards, and it's often the case that rather than having to go to each company and get a separate license, so if you wanted to make a Bluetooth device, you don't have to necessarily go to all of the companies and get a license for their patents that relate to Bluetooth. You may be able to sort of have a package license to make a Bluetooth device, and then the companies that have patents may divide up the royalty or the license fee that's received from that. And that simplifies things for the consumers or the people buying the Bluetooth devices, but also simplifies things for the companies with the patents, because they get a small royalty for each Bluetooth device sold, for example. So if you have new developments that may relate to, for example, data transfer protocols and may be incorporated into future standards, this is a potential revenue stream that you could consider, that often it's kind of a form of licensing, but you get a relatively small license fee for each product sold, because it's a relative, the whole cost of the manufacturer has to pay into the standard is relatively low, and that may be divided up by lots and lots of patent owners within the standard. But if lots of products are sold according to that standard, then potentially it's a large form of revenue. But the standard has to be widely adopted, and that the developments that you make would have to be part of that standard in order for your patent to qualify for that standard. And then finally, I'll talk a little bit about patent filing strategies for Southeast Asia. Now, at the beginning, I mentioned that for an invention to be patentable, it has to be new. And when the Patent Office is considering what's new, they look at the filing date of the patent application, and anything that was published before the filing date can be cited against that patent application. Now, that doesn't necessarily mean that if you want to file patent applications in lots of countries, you have to file them all on the same day, because there's a process known as claiming priority. So if you file a patent application, for example, in Singapore, you have 12 months in which you can file patent applications in other countries and claim priority, so claim the original filing date of the Singapore application. So this is the top option, which I call the Paris route. So in this case, if you filed in Malaysia, Vietnam, Thailand, and Indonesia and claim priority to a Singapore application, those 4 later patent applications would be examined as if they were filed on the filing date of the Singapore application. So any publications between the Singapore application and 12 months later wouldn't be taken into account in the examination. And there's a further option where you can effectively extend that period by another 18 months, and that's using what's known as an international or PCT patent application. And that effectively, if you file that at the 12-month stage, that gives you another 18 months, so 30 months in total, in which you have to decide in which countries you want to file patent applications. Now, the PCT covers most countries and most Southeast Asian countries, but not all countries. So, for example, Taiwan is not a member of the PCT. So if you want to file protection in Taiwan, you have to file within 12 months of your original application. And now I'll briefly mention a specific program in Southeast Asia that's aimed towards Industry 4.0 infrastructure and manufacturing. This was launched last year in August, and this is a program between the main patent offices in Southeast Asia, so Brunei, Cambodia, Indonesia, Laos, Malaysia, the Philippines, Singapore, Thailand, and Vietnam. The only Southeast Asian country it doesn't include is Myanmar, but there isn't really a patent protection regime in Myanmar. And under this program, if you get a patent granted in one of those countries, you can use that to accelerate processing in the rest of the countries. And the rest of the countries will have a turnaround time of 6 months from when you request an acceleration under this program to issuing the first office action. So that's the first examiner's opinion. And one thing that's notable about some Southeast Asian countries is the patent processing time or examination time can be very, very long. So using a program like this to get it down to 6 months to the first office action, sort of potentially 1 or 2 years for getting a patent granted, can be can accelerate the process a great deal. Another thing I would mention that may be of interest in Singapore is the patent fast track program. And this was sort of updated earlier this year in May. Before this, there were specific technology fast track programs for AI and fintech, but this new fast track potentially relates to all technology fields. It only relates to patent applications that were first filed in Singapore, but using this program, potentially you can get a patent granted in Singapore within 6 months. And the main requirement is that you have to provide some reasons why you want to request acceleration, and that can be related to the technology field. So if it's a fast-moving technology field, and one of the examples they've included here is Industry 4.0. So potentially IoT-related inventions could fall fall into that. And there's a relatively low cap of applications that accept under this program per month. And you also have to request search and examination on filing and respond to any objections in a relatively short period. So any formal objections within 2 weeks and any substantive objections within 2 months. But it does mean you can get a patent granted potentially within 6 months of filing. And that you can use as a springboard to expedite patent applications in other countries. So for example, if you first file in Singapore and then get something granted in Singapore within 6 months, you can use the granted Singapore patent to accelerate under the Aspect AIM program that I mentioned earlier on. And other countries outside Southeast Asia, for example, the US and Japan, have a PPH program, which means the Patent Prosecution Highway. And that also means you can accelerate examination based on a granted patent in Singapore. So one strategy, if you want to get patents granted relatively quickly, is to first file in Singapore and use the fast track program, and then use the grant received, the granted patent, to accelerate processing in other countries. And that's almost the end of my presentation. But now I have one final poll question, which is, following this presentation, do you intend to file a patent application for an IoT invention? And there's 3 options. Yes, I've already filed a patent application. Yes, I intend to file a patent application. Or no, I don't intend to file a patent application.
Okay, thank you, Jonas. So we leave a few seconds for the participants to select after understanding more on filing strategies. Okay, so I think we can share the result now. So what we can see is 50% intends to file a patent application, and 50% doesn't really feel encouraged to file a patent application. This is the result of the poll. And no one said that they have already filed a patent application.
Okay. Well, that's interesting, I suppose. I guess it depends a bit on the type of technology that you're implementing, whether there's a value in filing a patent application. But often a patent application can get you, as I mentioned earlier on, can be have a great commercial value and can help to attract investment. So I'm glad that about half of the participants are interested in filing patent applications. Okay, and now this is my final slide. So just to go over the points I made, a variety of different types of IP protection is available for IoT. Often the strongest protection is a mix of types of IP protection. So you may be able to protect your branding with a trademark. You may be able to protect your your software with copyright. You may be able to protect aspects of how graphical user interfaces work with registered designs, and you may be able to protect your underlying ideas with patents. Patents provide the strongest protection, but they're generally the most expensive, and they can take several years to be granted. So there are downsides in terms of costs and time involved, particularly for fast-moving industries. It's important to consider how the innovation will be used, both in terms of whether it's worth filing, for example, for a patent, but also what you want to cover with the patent that you may finally get granted. Another option is to keep things confidential, but it's very important to consider your strategy early on, because if you want to file a patent application, you need to get it on file before you disclose your idea. So before you start selling products, before you make it available to the public. And there are ways of accelerating patents, and specifically for IoT related patent applications in Southeast Asia, you can use this ASPEC AIM program. So thank you very much. That's the end of my presentation. But please do let us know if you have any questions, both for myself or for Jonathan.
Okay, thank you very much, Jonas, for the comprehensive overview on how to prepare an IP strategy if a company wants to do business in the IoT sector in Southeast Asia. I would like now to open the floor for the questions. So, Jonathan, if you can also unmute yourself, and I encourage the participants to send us any questions, and we still have a few minutes to discuss it. So maybe I can address my first question to Jonathan. So if a European company wants to understand what are the main challenges to overcome the deployment of a massive IoT, what would be your top suggestions or that you would name for the companies?
Okay, deployment. Okay, the IoT is being relatively new. So I think we spoke to various companies, and each of them have their different challenges. All right. So if I may say, is that I think the key hurdle is actually putting the IT department or the company together with the business or the operation team together. All right. Put this way, I've spoken to a lot of companies. So some of, for example, the head of maybe innovation or the various of a large company, and I mean, then the team will always be wanting to put in new stuff, whether IoT, whether AI, and so forth. And but the thing is, so they're always pushing the limit. But oftentimes the operation guys, the guy who's running the business or the business unit, doesn't have the time or may not be so forward-looking. All right. So I think the challenge, the key, the challenge, and also the critical success factor is to bring these two departments together. The guy who know the technology but may not understand the business so well, and the guy who know the business and operation very well but may not know the technology so well, is to put the two together. All right. And if the two don't come together, oftentimes it fails, or oftentimes it will not move beyond just the what I call the POC stage. All right. But if these two can come together, it has a right business objective beyond just show and tell, beyond just innovation for innovation's sake, then I think it really takes off. And once it really takes off, then I feel key things is actually then is to manage the process, to make sure there's a constant look, to make sure that the projects is moving correctly. Then I also learned quite a lot from Jonas earlier on regarding the IP, how to do it properly. All right, so that's also the part of the operation, because if issue like that is not handled, the project could fail along the way. All right, so these are important. Thank you.
Okay, thank you, Jonathan. And for Jonas, I would like to propose that we come back a little bit to the patent strategy, because we saw on the Q&A that we have half of the participants who intend to file a patent application, but there are several programs which exist, and I think it could be good if you can recap a bit more on how it would eventually take to get a patent under the ASPEC or the patent prosecution highway.
So typically under both of those programs, it takes around 6 months to get the first examination report, or the first sort of set of comments from the examiner. And that may be, if everything's in order at that stage, then patent could be granted in another sort of 3 to 6 months. So it could take around a year in total. Typically, it will take a little bit longer because there may be 1 or 2 rounds of objections. So I would say normally expect it to take, say, 18 months from when you request aspect or PPH. And if you follow the route, the very fastest route is if you use one of the Singapore fast track, then you could have a patent granted in Singapore within 6 months. You could file in other countries at the end of 1 year, and you could have patents granted in other countries after sort of 2.5 years from your start time. And that's probably the very fastest procedure to get patents granted around the world. Typically, it takes a bit longer. It normally takes kind of 2 to 5 years after you file a patent application. So if it's not the first patent application you file, it can take sort of the total time can be sort of 6 or 7 years. So using these programs can make the process much faster, and that can be very helpful because then you can sort of have more clarity about what you can protect with your patents.
Great, thank you very much for clarifying that. And yeah, so I have a question to Jonathan. If I am a German company and I'm very interested in doing business in Singapore, but I'm a little bit worried about the market, what would be your 3 tips to a company? What would be the 3 aspects that they should really consider when it comes to doing business in Singapore in the IoT sector? Why should they really consider to come to Singapore? So if you have to name 3 areas, what would be that?
All right, if I may understand your question, is that you're a German company with a specific perhaps technology or solutions, and you're considering why should you come to Singapore? So you want 3 reasons, right? Is that all right?
Yes.
Right. Okay.
To motivate them. Yeah, the purpose is to motivate them, to show the opportunities in the market. Yeah, thanks.
Okay, so yeah, Singapore is a unique place. Okay, I would say first and foremost, if you have not been to Asia, let's say all right, coming from Europe, Singapore is possibly the easiest place you can start off with. Number 1 is speak English, and there's a lot of aspects, European and American, Western aspects here. And also you have a similar kind of framework in business framework, very similar to the Western world. So from a standpoint, it's very easy for you to come in here. All right. Second, and it become, and Singapore, which is often Singapore position itself as a gateway to the rest of Asia, particularly to Southeast Asia. All right. If you come to Southeast Asia, it's a very big market. Indonesia got 250 million people in the world, probably the 4th largest, but in terms, and Thailand and so forth. But each of them in Asia have its own culture, its own language, its own framework. So it might get a little bit complicated for a Western guy in the first time. So Singapore become a very simple, easy first entry. Of course, the other thing is Singapore, while the market is not big, but the thing is Singapore have a lot of innovation and is quite well known as a smart nation in the world. So from a standpoint, you can possibly actually start many of your projects very quickly in Singapore. All right, and with that you can then try, and with the pool of the ecosystem, supply chain, and partners, you can actually possibly start things very quickly. And from that on, you can know how to fine tune and how to do it properly, and tune it for the Asian market. And once you have success, it is much easier then from here onwards to move on to the rest of Asia. If I may think, the 3rd reason is, all right, yeah, good food around here, many Western good food here. All right. Okay. I think the other things I would think the 3rd reason you can is that while Singapore is like if you put it this way, if you view Asia as a country, a continent with many different countries, but let's say it's one, Singapore was then like a city in the one of the major city in the midst, and it is a city then with many operational headquarters here. So, for example, right now I'm trying to work on certain supply chain tracking solution. All right. While Singapore do not have the factory, too many factories here. All right, we are small islands without many. But the thing is, many of the operational headquarters of the multinational company are based in Singapore. All right, so with it coming to Singapore, you actually is able to get in contact with many management and decision maker of large company that's in this region. So coming from Germany, for example, in my then quote example of DHL. All right, as I understand, I visited before. DHL had 2 global innovation demo center. All right, very large with a lot of innovating stuff showcasing there. One is in Germany, obviously, because DHL, and the other is in Singapore. All right, so it then shows. So why is it in Singapore? Because it is a regional hub. So I think that is where we would like to welcome you here. All right. Then maybe if I add the 4th area, if I may add the 4th area, is that the government is very supportive of technology and innovation. So if you have the right technology innovation, you can possibly get a lot of government help on this. All right, thank you.
Okay, thank you, Jonathan. And for Jonas, so as we convinced successfully the German company to expand their business to Singapore, what would be your 3 watch out message to the company that, okay, come, but please consider in terms of intellectual, in terms of building a safe intellectual property strategy?
I think as I mentioned, one important thing is to make sure that you can still use your trademarks and your branding in Southeast Asia, because if you weren't planning to expand to Southeast Asia, then there may be sort of other people blocking you using your trademarks in various Southeast Asian countries. So that's an important one. Another one is to make sure you have some IP protection in Southeast Asia, and you may decide you don't need, for example, to file patents in every country in Southeast Asia. Just work out exactly where the important locations for your business may be, and that may be, as Jonathan mentioned earlier on, it may be that sort of Singapore is your central hub, so then it may make sense to protect in Singapore. It may be that you have manufacturing in, say, Vietnam and Thailand, and then it would be important to get protection in those countries. It may be that your main place for implementation is Indonesia, where there's a sort of large population of people, so then it may be important to protect in Indonesia. And the final one is there are, as I mentioned, ways that you can sort of accelerate particularly patent prosecution in Southeast Asia, because one issue that many companies have in Southeast Asia, and particularly countries like Indonesia and Thailand, is that they file patent applications. It takes them a very long time to get granted because there may be backlogs at the patent offices, and their sort of workflows may not be particularly efficient. But there are programs, so like the Aspect program that I mentioned. There's also PPH programs between the EPO and various Southeast Asian countries. So consider if you have, for example, a granted patent in Europe, you may be able to use that to accelerate processing of patent applications in Southeast Asia, or you may be able to file a patent application in, say, Singapore, and once that's granted, use that to accelerate processing in other countries. So also consider the international programs between Europe and Southeast Asia and within Southeast Asia.
Thank you very much. So with that, I would like to leave the webinar here. I hope that all our participants got some useful takeaway messages from the session. Thank you very much for our speakers, Jonathan and Jonas, for joining today. And as mentioned in the beginning of the webinar, we will have a recording shortly available. Last small comment, we have almost already published our IP guide for the IoT industry. So it will be very, very soon available on our website under the industry section webpage. So we welcome all participants to check it out if they want to learn more on this topic. And with that, I would like to say goodbye to all of you. Thank you very much for joining and hope to see you at other webinars in the near future. Thank you. Bye.
Thank you. Bye-bye.